All right, hello again. What if we want to evaluate something a little more complicated like the inverse cosine of the cosine of 2 pi over 3? Now if you think about it, I mean, cosine and the inverse cosine, those are inverses of each other, right? So it's like inverse operations, and ideally they should cancel each other out, kind of like how squaring a square root would cancel it out. And that does happen, but you have to be careful because it only works under certain circumstances. So I'm saying that the arc cosine, the inverse cosine, can cancel out the cosine, leaving us with just this answer of 2 pi over 3. But you have to be really careful because this only works if the angle is in the range of that particular trig function. So for the arc cosine, its range being 0 to pi. Because 2 pi over 3 is between 0 and pi, which you can see on your unit circle, right? 2 pi over 3 is here, which is obviously in between 0 and pi. It works out. But look at the next example. Same scenario, except we have 11 pi over 6. On the unit circle, you can see 11 pi over 6 down here in the fourth quadrant. It's obviously bigger than pi. So, they can't just cancel out in this situation. So we're going to have to think a little bit harder. You're actually going to work from the inside out for this one. So first you're going to evaluate what is cosine of 11 pi over 6. So again, looking at the unit circle, there's 11 pi over 6. Remember, cosine is the x coordinate. So cosine is going to be square root 3 over 2. So what we have now is we're trying to find the inverse cosine of square root 3 over 2. And now this is a problem like we solved in the last video. So if we let this equal theta, what we'd be asking ourselves is, where is cosine equal to square root 3 over 2? So cosine theta equal to square root 3 over 2, but it has to be within our range that we know for the arc cosine, which is 0 to pi. So look on the unit circle, where is cosine equal to square root 3 over 2? But between 0 and pi. And that happens at pi over 6. Okay, so there's your answer. Now just like before, when I said we could check our answers on the calculator, that's still the case for this. So let's look at this one. We're going to type it in. Inverse cosine of cosine 11 pi over 6. We get that decimal, and we want to make sure does that decimal match pi over 6. Yes, it does. So we're happy campers, and we're going to move on to the next one. So on this one we have cosine of the arc tangent. And I mean, those functions don't even match up this time. So we're going to do something similar to what we did in the last one, except it'll be a little more complicated. So we're going to pull this out again. We're going to let actually theta equal arc tan of negative 5. And that means that tangent of theta has to equal negative 5. And we could try to solve this, right, by looking at the unit circle. But if you look at the unit circle and you have your tangent values written along it, hopefully, notice that tangent never equals negative 5, at least not at any of these exact values on the unit circle. So we can't use that technique. What we're actually going to have to end up doing is drawing a triangle for this. So we'll look at this as negative 5 over 1. We know that tangent is opposite over adjacent, right? So we're going to draw a triangle and label the sides that way. We need to figure out what quadrant to put our triangle in, though. So what we're going to look at is what's the range for the arc tangent. So the range is negative pi over 2 to positive pi over 2, which we talked about meaning either the first or the fourth quadrant. Tangent is negative in the fourth quadrant, right? So we're going to go ahead and draw the triangle in the fourth quadrant. Which means that this passes through the point. Opposite or adjacent. 1, -5. And if we use the Pythagorean theorem, we can get our hypotenuse. So 1 squared plus 5 squared has to equal c squared. That's 26 has to equal c squared. So c is going to be the square root of 26. Right, and if you want to label the 5 as a negative, you can, because that's going, in the negative direction along the y. And now we're going to go back. What do we have over here to actually solve? Well, we called this arctan of -5 theta, so we're trying to figure out what is cosine of theta. This is our reference angle in our triangle for theta, so we can use that to get our value. Cosine is actually adjacent over hypotenuse, so wouldn't this equal 1 divided by the square root of 26? Alright. And you can leave your answer like that. Okay, one more. This one is sine of 2 times the arctangent of 2. We're going to pull this out, just the arctangent of 2. And we're going to let that equal theta. And that means that tangent of theta has to equal 2. Alright? Which we can draw a triangle to represent this scenario. Put it in quadrant 1. Tangent's opposite over adjacent, and then we can get our hypotenuse again, right, with the Pythagorean theorem. That's going to end up being square root of 5. And now we're going to come back and figure out what do we want to actually find. We want to find sine of 2 theta. That's not as straightforward as the last example. We just needed cosine of theta, so we could use the triangle directly because we had made the triangle for theta, right? In this one, 2 theta, it's a double angle. So we actually have to go and look at the formulas for double angles. We did a whole section about double angles. A piece of advice is either go through all the sections that we had done in class with all those formulas and write them all down in one location so that you have them. Or if you want to go online, if you search trig cheat sheet, this PDF that you'll find has every formula you could ever imagine needing for trig stuff. And I'll show you what the page here looks like. Here's the double angle formulas right here. Right by my finger right there. Look at what sine of 2 theta is. See, sine of 2 theta is 2 sine theta cos theta. And we can use this now because we have a triangle for theta, so we can figure out what is sine of theta from the triangle. Sine is opposite over hypotenuse, so it's going to be 2 over the square root of 5. And then what is cosine theta? It's adjacent over hypotenuse, so it's going to be 1 over the square root of 5. And then multiply it out, you end up with 4 over 5. So 4/5 is our final answer for that one. Alrighty, that's it for this one.